Normal distribution, you want most data values to be near the mean, and so you want to have like a peak in the middle. So like kind of like this, like most values are near the mean, you got a peak in the middle. Data values are spread out evenly on either side, so you got as many low ones as you do high ones. Larger deviations are rare. Okay, you don't have like super large deviations that would cause a tail on a certain side. And individual data values result from a combination of many factors. Okay, so scores on an easy test. So scores on an easy test. Let's think about this. If this test is easy, I like drawing this out. So let's look at scores on easy tests. So scores, and then students. So like if it's an easy test, aren't most of your scores are going to be up in this area, right? They're going to be up here because like in 100% or so is the highest. So there's not really a way to go further on this end. And then you might have a few on that one. So that one appears to be skewed left. So this would likely be skewed left because you would have a huge cluster. You'd have a huge cluster around the up, like the A area, probably A's and B's, and then fewer lower scores would spread out. And so you'd have maybe a few low scores that would create a tail on that side. So you'd have many high scores and a few low scores. And the few low scores would potentially create a tail. Like if you had a student that just still, it's an easy test, but still they didn't really pay attention or weren't going along with it. Put length of random sample of adult women. So this is determined by many genetic and environmental factors. We expect women's feet to cluster near the mean and become less common farther from the mean in both directions. So this one I would expect to be normal. So like the lengths of women or length, and then the women here, you would have a few on the, few small feet, few large feet, but they'd be mostly clustered around the middle. So this one should be, you could say normal. Sometimes I like to use the word nearly normal. Um, I would say nearly normal or slash normal. Okay. Because it's never going to be perfectly normal. Okay. And really, it goes back to step 4 here. Data result from a combination of many factors such as genetic and environmental factors. And so, like their the length of feet are genetic factors. And so, those, that's going to kind of determine um, you're going to have a cluster of values close to average foot size. So like you're going to have a cluster here, not side size. So like you have a cluster here around the average with a few smaller and larger sizes. Okay, so they're going to kind of balance each other out, keeping it symmetric.